So we have seen the break statement, which is a statement used when you are in the middle of a loop and you encounter a condition and you want to exit the innermost loop. There will always also be occasions in your program when you are in the middle of a loop and you encounter some condition, and then you realize that you don't need to execute this iteration, you just can go to the next iteration. So skip the current iteration. The break statement was you encounter a condition and you say I am done, I'll exit out of the innermost loop. Here it's not exiting out of the innermost loop, it's just skipping the current iteration. Okay. For this we'll see the continue statement, and let's motivate this by an example. So continue, the statement causes the next iteration of the closest enclosing for, while or do while loop. Okay. Let us motivate it with a very simple example. Let's say that we are reading numbers coming in a stream, and what we have to do is to skip the negative numbers. So you have to read all the positive numbers, and reading should be finally over when you encounter some input which is not a number. Okay. How do we do this? Let's imagine that you have the main and things like that written, and the central part of the code can be analyzed as follows. So you have integer variable a, and let's examine the code in closer detail. So what we need to do is, we may have an input sequence that looks like this: 1, -1, 2, and then dot. Okay. So let's say that the input sequence is something like this. What we will do is, we will do the scanf operation to get the numbers. So scanf operation will read the first entry as 1, it will read the second entry as 1, the third as -1, and the third entry as 2, and so on. Okay. So that is what scanf %d address of a. We are already familiar with this. But what does equal to 1 mean? Okay. So this is something that we have not encountered so far. The scanf statement has a return value. Okay. It gives you the number of inputs that was successfully read. For example, we are trying to read an integer in the %d specifier. Okay. So when we try to read the first entry, it should succeed. So this will succeed. When you try to read the second entry, it should succeed. When you try to read the third entry, it should succeed. In all these, the scanf %d will return a 1, because one entry has been read correctly. Here it will fail, because it tries to read a natural number here, but what it sees is a dot, okay, a full stop character. Now that's not a number. Okay, so scanf %d will simply fail. So this is what I said, it returns the number of conversions that have been successfully made. So when you try to read an input like 1, -1, 2, dot, it will succeed in the first 3 scanfs, and the last scanf it will fail. Okay. So that's what the scanf is supposed to do. So as long as you have read a number, so while you have read a number, you examine whether it's a positive number. If it is a negative number, that is if a is less than 0, then you say continue, which is saying that okay, I don't need to execute the remaining part of the loop. So this part of the loop will be skipped if a is less than 0. Continue means go from here and start executing the next iteration of the loop. Let's go ahead and complete the code. So let's modify the problem a little bit. Read the integers until a non-digit is found, and let's do something with the positive integers. Let's say that we have to find the largest of the positive integers. So what should we do? Again, let's try to do it by hand to get a feel for what I should be doing. So I have 1, -1, 2, dot. Let's say that I initialize the maximum to some reasonable value. Since we are looking at the largest of the positive integers, I can initialize maximum to 0. Then I look at the first one, the maximum read so far, so it's a positive entry, so I will update max equal to 1. Okay. Then I read the next number and it's a negative number, so skip it. Then I read the third number, which is a positive number, so I will update the maximum to 2. Okay. So this is the part that we want to focus. If it's a negative number, skip. Okay. So here is the code for doing that. While the currently read number is while the currently read input is a number, that is why the percentage D succeeded and one entry was correctly read. Okay. So if a number was read, check whether the number is negative. If the number is negative, continue. Continue means go to the next iteration of the loop. Do not do what is remaining in the loop. Okay. So if the currently read number is non-negative, what you will check whether the current maximum is less than the new number. If it is less than the new number, you reset the maximum to the new number. Okay. So this is the code that we have written, similar to other codes that we have seen. So you update the maximum number, and go and read the next number. Okay. If the currently read number is negative, then we will say continue. So we will not update the maximum. So this is what the continue is supposed to be doing. Now, as in break, you can also write equivalent code without using the continue statement. So let's try to do that. And for doing that, all we have to do is make sure that the maximum is updated only if it is a non-negative number. Okay. So this says if it's a negative number, do not do the next statement. This says if it is a non-negative number, then update maximum if necessary. Okay. So it can be written with one more level of nested if. So this says that if A is non-negative, then execute the next statement. Okay. Here it says that if A is negative, then continue, which means skip the next statement. Okay. So notice that these two conditions are the negations of each other. The long and short of it is that continue is not really necessary, but if you have it, then it is useful and it makes the code clearer in certain occasions. What happens to continue in a for loop? Notice that for loop has the following form. You have for, then there is an initialization expression, okay. Then there was a test, and finally there was update. And then you have the body of the loop. What happens if you encounter a continue in the middle of the loop? Okay. In the case of a while loop, it's very clear. You go to the test expression, you go to the next iteration. The only contention is in the case of a for loop, do you go to the update statement? Okay. And the answer is yes. When you skip the remaining part of the loop, so this is the part in the remaining part of the loop that you will skip. When you skip that, you go directly to the update statement. Notice that when you do the break, so if the statement was a break, you break immediately out of the loop without doing the update. In the case of a continue, you have to do the update. Okay. And as with the break statement, the continue statement is also redundant. You can program without using the continue statement as well, but it is useful if there is already a few levels of nesting of the if statements inside. We saw in the previous we saw in the previous slide that you could avoid continuous statement by using an extra level of nested if statement. Now, if you don't want to complicate the code in that way, you can use a continuous statement. Otherwise, in other cases, you may want to exit out of the loop. In that case, you can use the break statement. Okay. So they are extra feature that the C language provides you. They're not really necessary, but they are useful.